And so today we're looking at Chapter 2, Section 7, graphing absolute value functions. Okay, so the goal by the end of the day, you want to be able to graph absolute value functions. Make sense? You're right. So your parent function for absolute value functions is right here. You have y equals the absolute value of x. Now remember, with absolute values, anything we put inside these brackets there is going to make the number positive. So if I plug -2 in, I get +2. I plug -3 in, I get +3. Your absolute value sign, it makes everything inside of that positive. So if we wanted to graph our parent function, we got a picture over here I already gave you guys in your notes. So if we kind of see over here, we have 0, comma 0. That's going to be our vertex. Okay, so the vertex is your highest or lowest point on the graph. So vertex here is at 0, comma 0. And then a good general rule of thumb to help you when you're graphing functions, absolute value functions, any kind of graph, if you can find that vertex for these, find that vertex and pick a couple points to the left and right so you get that full picture. Okay, so if our vertex is at 0, 0, I graphed 1, I went over to 1 and 2, and I went back -1, -2. So that's how I got my table there, and that's how I would have graphed this. Okay. Um, Now, if I want to look at my parent function over here on Desmos, I'm going to use Desmos to kind of help visualize some of this stuff. So here's my parent function, y equals absolute value of x. Kind of the bigger ideas here is we want to find a quick way to identify our vertexes for these functions. It's going to make your life easier when you're graphing, making your tables. It's going to help you on the quiz, your homework, assignments, whatever. You want to be able to find a vertex really quickly. So if I have an absolute value function that looks like this y equals absolute value of x minus h plus k, the vertex is going to be h comma k. So down here, it's pretty important stuff. Your vertex, if a function looks like this, your vertex will be at h comma k. So h is this number that's being subtracted from x, and then your k is what's being added at the end. Or it can be subtracted. We'll see a couple examples of that. I'll show you both. So again, if I go over here, I have my parent function, and now I want to add a second function. So let's say I do y equals, let's do absolute value x minus 1, minus 1, close that bracket, and let's do plus 1. Whoops, I went back. So I go plus 1. All right, so I have the same function here, except I shifted right 1 and up 1. Okay, I shifted right 1 and up 1. So my new vertex is at 1, comma 1. So if I look here, I have y equals absolute value of x minus 1 plus 1. This looks really similar to what's in our notes over here because it is the same setup. So my h comma k on this function, here's my h is 1, my k is 1, so that's why my vertex is at h comma k, or 1, 1. All right, and we can check that here with another example. Let's do x, let's do plus, no, let's do another -2, and then we'll go -3. Okay, so now h comma k, h is 2, so my vertex is going to be at 2 comma something. I'm subtracting 3, so it's going to be 2 comma -3. And sure enough, I have my graph here, and the vertex is at 2 comma -3. So if I wanted to make a table, or if I'm graphing, it's not my homework, I want to go over a couple points, so I'd probably graph this point here, I'd graph this point here, and I'd graph here, and I'd graph here. So, graphing 5 points, your vertex plus 2 to the right, 2 to the left, pretty good idea. One more example now. Let's say I do y equals absolute value of x, and let's say I go plus 2, and I go -1. So I have the function, it looks just like my parent function still, except I shifted left 2 this time and down 1. All right, so I went left 2 and down 1. So because I'm adding 2, I have x plus 2. That's the same as doing x minus negative 2. So if we go back over here, our vertex is at h comma k, and we're assuming that we're doing x minus h. All right, but over here we have x plus h. That's the same as doing x minus negative 2. So if I do x minus negative 2, now it's easy. I say, oh, h is negative 2, k is negative 1. So my vertex is at h comma k, negative 2, negative 1. Sure enough, there it is. But if I have plus 2, that just tells me I'm subtracting negative 2. So that's why if I'm adding to that x, I'm going to shift to the left. And if I'm subtracting from x, I'm going to shift to the right. Okay? So if we pull that example off the screen, there we go. So when we added 2, we shifted left 2. Whoops. Added 2, shift left 2. Subtracted 2, we shifted right 2 spots. Okay? And then our k's, we go down 3 for this example. And for this example here, we went down 1. So if we look at these a few examples now. So if I have y equals absolute value of x minus 2 plus 3, okay, here's my h is 2. It's positive 2. I'm subtracting a positive 2. And then my k is 3. So I'm going to do this real quickly. 2, 3. Got my vertex. All good to go. I know that's where my vertex is. That's what h comma k is. I go to this next one. Okay, I have x plus 5. So remember on this graph over here, when we added 2, we went left 2. So if we add 5, we're going left 5. It's just like I'm subtracting negative 5. So my vertex for this one's actually going to be negative 5, comma, negative 4. So I have negative 4 for my k. Okay, so right there we can see k is negative 4. And for this last example here, I'm subtracting 2.5. So h is 2.5, and I'm adding 3.5 at the end there for k. So boom, got my vertex 2.5, comma 3.5. Really quick. Once I got this formula down, I know what h comma k is my vertex. I can find these vertexes really fast. I don't need a graph. I don't need to do a table. I don't need to punch anything in. I can just look at the equation and find them. Okay. So if I want to graph y equals x, absolute value of x plus 3 plus 4, that vertex, actually I'll get it really fast. So I'm x plus 3, that means I'm going left 3, because that's the same thing as doing subtracting negative 3. So my vertex, I have negative 3, comma 4. So if you want to graph that vertex, it's going to be at, go over 1, 2, 3. I'm going up 4, 1, 2, 3, 4. So here it will be my vertex. And if I wanted to keep graphing this, you can make a table. So you can plug in negative 2 into this function. You can plug negative 1 into this function, and then plug in negative 4 and negative 5 into this function as well. But since I just have, remember it's my absolute value function just shifted. So I'm going to be going up 1, over 1. So I have a point here. I have a point here. I'm going to have a point here. I'm going to have a point there. So I just connect those dots to make my graph. Now you can probably do a prettier one on with your pen and paper, but here's kind of a sketch of what that function is going to look like. So moving on now to the last part. We're looking at now different examples. So if I have a number, we'll call it a, out in front of that absolute value sign, that's going to change my graph. So if the absolute value of a, that number out in front of my absolute value, is greater than 1, then the graph is narrower than y equals absolute value of x. If that number is less than 1, then the graph will become wider than my parent function y equals absolute value of x. If a is negative, then the graph is reflected over the x-axis, and my graph will open down. If a is positive, then the graph will open up. Okay, so quick summary, and I'm going to show you on Desmos what this all means. If that number, the absolute value of it, is greater than 1, I get a narrower graph. Absolute value is less than 1, the graph is wider. If it's a negative number, it flips down. If it's positive, it opens up. Okay, so we go back over here. I go back to my parent function. Here it is. Now, if I add a number out in front of it, if I add a number, so like 2 times the absolute value of x, I just got narrower, okay? So here's my a value is 2. It's greater than 1, so I get narrower, all right? Let's say I want to get even narrower now. Let's do 4 times the absolute value of x. I get narrower, all right? So the bigger this number gets out in front, the more narrow it becomes, all right? Now let's say that I flip my parent function. So I flip it. So all I did now is I made my parent function flip over the x-axis by putting a negative out in front. So it could be -1. Same function, just flipped upside down. And now if I do the same thing here, I'm still going to be narrower. I'm just flipping those graphs down upside down as well. So I take this one, put a negative sign out in front of it, and that still holds true. So all of those graphs just got flipped, but we still see the absolute value of -4 is +4. So that's going to be narrower than this green function here, this green one with an absolute value of +2 for my a. My a is -2, so the absolute value is +2. So this one is narrower than this one, and this one is narrower than this one, okay? And all of these graphs are opening down because I got a negative sign out front. The last thing we want to look at is when we get wider, okay? So I'm going to go back to my positive ones. So we'll go, there's my parent function. Actually, let's cancel these out. So there's my parent function. Now I want to see my graph get wider. So my a value, that number out front, has to be, the absolute value has to be less than 1. So I have y equals, let's go 0.5 times absolute value x. And we just got wider, right? So we got wider. Let's do another function even wider than that one. I'll do 0.5. And look, we got wider yet. If I change this number, I keep making it smaller. My a keeps getting smaller. Then it's just going to keep getting more and more wide, right? So like that, it doesn't even move. The smaller that a is, the wider it becomes. Same thing holds true. If I make all these negative, now I'm just going to be flipping them upside down, all right? So they're going to be opening down, but it'll still hold true about them getting wider. So still just as wide as they were before, but they're just upside down. So if we have a positive a, it opens up. If that a is absolute value of a is greater than 1, it's narrower than the parent function. If it's less than 1, it's going to be wider than the parent function. So that's kind of all of this stuff, all right? So these next couple examples, I'll kind of get you started on them. So if I'm graphing y equals -1/2 times the absolute value of x plus 1 plus 2, do I know if that graph's going to open up or down? Is it going to be narrower or wider than my parent function? And can I find my vertex? Well, I should be able to do all 3 of these things just by looking at my function. So is it opening up or down? Well, my a value here looks like it's -1/2. So a -1/2, it's going to be opening down, all right? So I'll try circling that. Looks like I just kind of canceled it out a little bit. But it's going to be opening down, so I tried circling that. Okay. And now, is this graph going to be narrower or wider than my my parent function? It's going to be wider, right? Because my absolute value of -1/2 is +1/2, and 1/2 is smaller than 1. So up here, it's going to be wider now. So here's wider, okay? There we go. We circled that one better. And then my vertex now is going to be at h comma k. So h, we're adding 1, so that means we're going to go left 1, right? So we're going to go left 1, which is the same as doing x minus -1. So my vertex will be at -1, comma 2. K is 2 there. So now I got my vertex. I know which way this graph is going. I know it's going to be wider than my parent function. And I can make my vertex at -1, comma 2, okay? And you can finish this table on your own. We'll go over this in class and finish this together. And then my next one here, we got, get over here. I scroll down. I'm graphing y equals -2 times absolute value of x, and I'm adding 4. And I'm going to actually leave this one for you guys to try on your own completely. So I got this first one started. You just got to finish making that table and graphing it. So remember, for making the table, I want to pick some points to the right of my vertex, pick a couple points to the left, so that gives me that complete picture. That's about all I got for you guys today. Everything else we'll handle in class. Hope you enjoyed the video. First one. Maybe we'll do some more.